Hello maths fans, I'm Dr. Tom Crawford. I teach maths at the University of Oxford and the University of Cambridge, but today I'm going back to school to try an exam from France. This is the Baccalauréat General mathematics paper, which is taken by students in France when they graduate high school, so around the age of 17 or 18. The specific paper that I will be sitting today comes from the 2024 series of exams, and this one was labelled as day 2. Now the instructions tell me that I have a, quite frankly, ridiculous 4 hours in which to complete the 4 questions of the exam. Now, as usual, I have not yet looked through the paper, so I have no idea how detailed these questions are and whether I will need the entire 4 hours. However, I'm going to preemptively state that it is very unlikely that I'm going to answer all of the questions, right? I don't think you all want to watch me doing maths for 4 hours, and to be honest, I'm not sure I want to sit an actual 4-hour exam. So we will see how I go. I will try and do as many as I can, but just as a warning, I'm probably not going to do every single question if it really is going to take me 4 hours. And a final point, the exam is of course written in French, which means I have translated it with a very basic online translation, so there may be some issues with me trying to understand the French and English versions, but hopefully I can figure it out using the graphs and the equations. Right, I think that's it for the admin, so let's do some maths. Exercise 1 for 5 points. Feels like it's going to be a low scoring exam then. There are only 4 of them. The headmistress of a school wishes to conduct a study among students who've taken the final exam. We're doing the final exam to analyse how they believe they succeeded in this exam. Of course, I'm reading the translated version here. For this study, students were asked individually after the exam to answer the question, do you think you passed? God. Only yes or no answers were possible, and it was observed that 91.7% of the students surveyed said yes. Okay, so I feel like that's important information before I even get to the question. So question 1, so I'm saying the probability of saying, answering yes is, what was it? 91.7%, so that's 0.917. Okay, it's gonna make me use a calculator, isn't it? I can already tell, and of course I don't own a calculator. Come unstuck many a times, but anyway. Right. Following the publication of the exam results, it was discovered that 65% of the students who failed answered no. Okay, so 65% of those that failed. So it feels like we're doing a conditional probability straight away, because it's saying if they failed, then they answered no. 65% of the students who failed said no. So I'm saying like the probability of no given they failed, I think. So we know that they failed, and then the probability of no is then 0.65, right? Again, to sort of talk you through my process, I haven't yet read the question, but it's giving me a lot of information, right? You can see on the page there's a whole paragraph of stuff. So I'm just like trying to translate, right? I've translated the French into English, and now what I'm trying to do is translate the English into equations. So again, I don't know if I'm going to need any of these specific things I'm writing down, but I'm just trying to keep track of like what is the question telling me, and then I can come up and look at what I'm actually being asked to do, right? This is just how I generally think about these kinds of long form problems. So it looks like if it's only 5 points, these are going to be very involved problems, right? It would appear. Okay. And then we're also told, there's a second one here, 98% of successful students answered yes. So that's saying the probability of yes given they passed because they were successful, and then I've been told what that value is, and that's 98%. Okay. So it's saying if we know they've passed, 98% of them said yes. That's the third thing I've written down. If we know they failed, then 65% of them said no, as in they knew they'd failed. Okay. And we know the total probability of like how many actually passed, right? No, how many answered yes? Not how passed. How many answered yes to the survey? Fine. Okay. Right, now. Right, so it's trying to tell me what these letters mean, and it's not translated the symbols very well, but anyway, I think I make sense of it. So it's saying R is the event the student passed. Okay, so R equals event student passed. Right, so this is just, I think, introducing a notation for what I've just written down, which is fine. And then the other letter we're going to use, Q, is going to be the student answered yes. Okay, so Q equals event student answered yes. Okay. So again, lots to write out before we get to any actual questions. For an event, we note P of that to be its probability, yes, and then A bar to be the opposite, right? Yes, it's the normal notation. So it's saying then R bar means fail, R bar means fail, and Q bar means answered no. Okay. Because if you don't pass, you must fail. That is like the complement. And if you didn't answer yes, you must answer no. It says there were only two options. So that's the complement. All right, finally. Oh, and then something about probability rounded to 10 to the minus 3. So 3 decimal places. Okay. So I'll just kind of write that up there. I mean, we know that I'm not going to actually do that because I don't have a calculator, but anyway. Right, questions. First one. What is the value of the probability P of Q? Okay, so this is actually part 1. So I want to know the probability of Q. So the probability is the student answered yes. So I wrote that down. That is just 0.917. Right, I'd already written it down. So I've answered that question. Oh, and then P, okay. P subscript R bar of Q bar. So I think what that is asking me to do, given what I've written down, right? So if I were to go back up here now, and use a different color. So R bar is fail, so that's R bar is to fail. To pass is R, and then I want to know answering yes is Q, and then this is Q bar. Right. This is not notation that I am used to using, that we would use in even at university, probably not even in the UK, but I feel like given what the question is asking me is just what I've written down before. So I think what this means is it's asking me, what's the probability of Q bar? So what's the probability that the student answered no, but then it's got this subscript R bar. So I think that means given we're in the space where we know R bar has occurred, right? So we know the student has failed, and then it's saying, given that, what's the probability that they said no? And that's exactly the probability that's been given, and I've written down from my original thoughts. So I'm pretty sure that that is going to be 0.65. So it would make sense that the first thing they're asking you to do is to do what I already did by default, right? Is to translate the words into mathematics. Okay, cool. And that seems to be it for question 1, right? But not, of course, the whole exercise, just there are like exercise 1, and that is question 1. Within it, there seem to be 6 questions within exercise 1. But anyway, we done one of them, don't complain. Okay, right. Now we're going to specify something, yes. Oh God. So I think what this is saying now is X is the probability that they pass the exam. Yes. So I think X means that they passed, right? So we're saying that the probability of R equals X, right? Something. So then we know from that, right? We know that R bar is 1 minus X. So we know that. Okay. And I believe it's asking me to complete the tree diagram. Now what does... Okay. Cool. Right. So I think it's asking me to complete the tree diagram. I could sort of figure that out myself based on the picture, but the translation confirms this. Right, so we start here, and then we're going to R and R bar, And then from R, so from passing, we then want to know, did they answer yes, which would be Q, or did they answer no, which would be Q bar. And then here we also want to know those two possibilities. Okay, now I'll add the probabilities in red, just again to make this clear. So we know that that's X, they've told us that, so that has to be 1 minus X. There's no other possible outcome, right? You pass or you fail, so we know it's therefore 1 minus that, because the total probability has to be 1. Now, we've written down a few things. So we know that what? Given R bar has happened, we then know that Q bar is 0.65. So I can write that one in. And again, the total probability has to be 1, so this one has to be 0.35. So that the total, right? So given you have failed, you must have answered yes or no. So we know what the probability is that you answered no, so therefore it's 0.35 that you answered yes. Great. And then the other one we've worked out is what? I wrote this down. I said probability given R has happened, given that the student has passed, probability of yes is 0.98. So that's this one, isn't it? So that's 0.98. Fabulous. So that means this one must be 0.02. So that means they passed and then they said they didn't, right? And let me just check what that statement was. 98% of successful students answered yes. So they're successful means R has happened, they've passed, 98% yes. Fine. Okay, I'm confident that is my tree diagram. And now it wants me to show that X is 0.9. Right, so just to kind of take stock here and do some good exam technique for once, having done many, many exams now. It'd been a while since I had, but obviously in the last few years I've done quite a few exams now. I am starting to remember classic exam technique. So what I mean by this is we've used, so I've used that, I haven't yet used this, right? Haven't yet used the 0.917. So I'm going to hazard a guess that now it wants me to show that X is 0.9 is going to require some equation that's going to use that. Is what it feels like to me anyway, because why else would we have written it down? So what would that mean? Okay. So we know that the total, okay, so the probability of Q is 0.917. So that's the probability that the student said, yes, yes. Okay. Now, if you're going to say yes, you could pass. Okay, so this has to be the same as saying, I'll just write it properly. So the probability of Q given R plus, oh, but if I write it as given, it's like a partition. I want to use the partition theorem, which is maybe more advanced than what you're meant to do here. I don't know if the partition theorem is part of the French syllabus. I have no idea. Because then I would have to multiply that by, so yes, okay. I'm just going to write the partition theorem. So the partition theorem says, so I'll just write here, by partition theorem. So this allows you to break up a probability, right? So it's saying, the probability that the event Q happens is the probability that Q has happened given R has happened, but then you have to multiply by the probability of R, plus the probability that Q happens given R bar has happened, multiplied by the probability of R bar. Okay, and that's going to allow me to introduce X. So I think that is a true statement, and now I'm going to use my tree diagram to like figure out what all of these things are, basically. So from the tree diagram, I can now fill in these values. So the tree diagram says the probability of Q, so that's just 0.917, we know that. Now, Q given R, so R has happened, and then Q is 0.98, and then that's multiplied by the probability we went down the R branch in the first place, which is X. And then we've also got Q can happen having gone through that one, so that's 0.35 from my diagram times 1 minus X, the probability of R bar. So this now gives me a nice equation for X, and I'm going to hopefully solve this and get 0.9. But just to kind of go over that with the picture, right, I'm trying to work out, I'll circle these in the highlighter. So we can have Q here where R has happened, or we can have Q where R bar has happened. And then what the partition theorem is telling you is to basically multiply along the branches, right? So I'm going to hazard a guess this is taught, most likely anyway, is taught through the tree diagram, right? How to interpret it. But the partition theorem as I've written it is how I would teach this to my first year students when they're doing probability here in Oxford. So, you know, it's just a more generalization where you don't need the picture, but it's the same thing. Right, so I better solve this now and hope, I'm saying all this, I don't know if it's going to work, but I think it's going to work. It looks about right. So that is equal to 0.98x plus 0.35 minus 0.35x. So if I take 0.35 across, 917 minus 35 gives me 882. 0.882 is therefore equal to 98 minus 35 would take me down to 63. 0.63x. So I think that x is equal to 0.882 divided by 0.63. That's going to be too big. Okay, so I did something wrong. Oh, that's annoying. Because that's going to be way too big. Because it's not minus 35. Nice example for you all there. Let's pretend I did it on purpose, as always. I made a mistake, didn't I? Because I've taken away, it's not that at all. So it's 917 minus 350, right? I did 35, that was very silly. So that's 350 of x there. Okay, putting it to 3 decimal places, right. So 917 minus 350 is going to give me like 567. I think it's 567. Let me just double check that now. 0.567. So if I have 567 and then I add on 300, that gives me a 867 and then plus the 50, 917. Yes. So now this looks correct because what dividing by 0.63 does, it's like call it 2/3. So it multiplies your number by 1.5. So if we're starting at 567, then we multiply by 1.5. That's like 0.6 times 1.5 is about 0.9. So I think it will all work out in the wash. So that I think is correct. I'm just going to say equals 0.9 when using calculator, which of course I'm not going to use because I don't have one. But that is going to work. Right, that equation I am 99.99% certain is going to give me 0.9, the answer they wanted. Great. Okay, so 2 was more involved. 3. Where are we going next? I was about to read it out in French, don't do that. The student interviewed answered yes. Okay, what is the probability they pass the exam? Okay, so we know that we are given yes. Okay, so we want the probability of pass given we know that they answered yes, right? So again, I'm just writing this down using my conditional formula. Now I'll convert it to Q's and R's and then I'll use my diagram. So passing is R, and we know they answered yes, which is Q. So I want the probability of R given Q. So the probability of R given Q. But what do we know here? Gosh. So I know the probability of R. I think I want to use Bayes' theorem to like flip the order because all of the ones I've written down have R in the second position and here we've got R in the first position. So I think again, if I use possibly more advanced techniques than I'm supposed to, but still correct maths. So Bayes' theorem here says, I'm going to write it down. So it says the probability of A given B is the probability of A and B divided by the probability of B. Right, but we can also say that the probability of B given A is the probability of B and A, which is the same, divided by the probability of A. So what it means is, so therefore, no, I can just use that one then, can't I? Yes. So I want probability of R given Q, right, and not R given G. I'm doing probability of R given Q, right, is therefore, I want the Q1 on the bottom, I think, is the probability of R and Q over the probability of Q, but R and Q, gosh, is from the top, R and Q is the probability of, okay, think about this now. I want to combine the two Bayes theorems, so let me just do that. I think I'm going to erase this. Let's just, I'm doing my usual thing where I try and rush through steps and make mistakes, and I'm going to try and learn from the mistakes I make in these videos. So I want to combine these two, and the point is that I can say, therefore, the probability of A and B together is the probability of A times the probability of B given A, and it's also equal to the probability of B times the probability of A given B, right? So I'm kind of swapping the order of A and B, but A and B is the same as B and A, so I can construct this equation. So I'm kind of saying this is now the equation I want. So the one that I want to swap the order, so therefore probability of B given A is the probability of A given B, right, yes, times the probability of B divided by the probability of A. And now I've got something explicit I can write in terms of R and Q. So, because I know Q given R. So therefore, the probability of R given Q is the probability of Q given R times the R1 on the top. Probability of R divided by the probability of Q. Okay. So a very roundabout way of getting the formula I wanted, but now I think I know what all of these things are, right? So Q given R, I wrote down up here somewhere. Probability of Q given R is 0.98. Yes, so that's 0.98. Times the probability of R. So R was passing, yep, so that's X, and we just worked that out as 0.9. And the probability of Q, I think we knew that. We wrote that down in the beginning, was 0.917. Amazing. Okay, so the answer, I think, is that. Right, again, don't have a calculator. I will just write here, plug into calculator. It makes sense. I'm going to get something smaller than 1. Not much smaller than 1, but something smaller than 1. So the probability that the student passed, given that they said yes, is going to be pretty big. Yeah. Feels right. Okay, plug into calculator. That is the answer. Right, that was 3. I hope that was 3 at least. Okay, it's nicer when they tell me show x is 0.9. As I said, I think this is going to be quite a high number, but hopefully it's right. The grade obtained by a randomly selected student is an integer between 0 and 20. Okay, so doing an exam out of 20. I'm going to guess this exam is probably out of 20. It is assumed to be modeled by a random variable binomial. Okay, what letter are we using for this? We're using N. Right, so we're being told, a stats question following the probability. So it's a binomial, and we've got 20 numbered, yep, and 0.615 is the probability then. So I'm guessing, is that 20 students? I think it is 20 students then, and 0.615 is the probability of them passing. Right, if you interpret binomial NP means n events where the probability of success is P. So I think this means 20 students where the probability is 0.615 of them passing. Okay, that I think is my interpretation. Just of course it didn't ask me for that, but I'm doing my thinking out loud. Okay, the director wishes to award a prize to the students who achieved the best results. At what grade level should she award the prize so that 65% of the students are rewarded? So this is a question of, at what point in the binomial do we get so that 65% of them get the award? Oh gosh, okay. So this is about sampling from a binomial, basically. So, right, so we want want 65% to be greater than some number x. So 20 is the number of marks. My apologies when adding them up. Right. Okay. So, yeah, that makes sense. 6.15, so it's saying like 12.3 is the average. Okay, fine. So 12.3 is the mean. So it's going to be a little bit higher than that, I think. No, a little bit lower than 12.3, I think. Right, so the mean mark is NP for a binomial. So that's going to be, let's just write this down. So NP is 12.3 marks. So if we're wanting, so that I think would mean, that's the average value, you would expect approximately half below, half above. So we're going to get a mark that's going to be a little bit lower than that. This doesn't really, I don't think this helps me answer the question, but it gives me an idea of what the answer should be, so I can like make, it's like a sanity check, isn't it, right? And we like sanity checks. We expect a mark around 12-ish. Now, I need to sample from a binomial. So what I'm saying, let's call that lowercase x to make sure it's not a random variable. So what I'm saying is we want 6% greater than x, so that implies the probability that the sample from our binomial is greater than or equal to x should equal 0.65. Right, now that should now allow me to then sample from a binomial. So what you would do here, again, I don't have the calculator, so you would say now, e.g. check, what's the probability that n is greater than or equal to, I don't know, 12, right? And that's going to be some number, probability that n is greater than or equal to 11 equals ... etc. Right? So you would just like try some numbers with the binomial. So you would take out your scientific calculator, which I don't own, and you would say, for a binomial with these parameters, so n is 20 and p is 0.615, right? So this is n and this is p. So you'd say for that binomial, what's the probability that I sample greater than 12, right? And you want to know what that probability is. And somewhere around here, right? So I'm gonna really spell out how I would answer this. So somewhere here, you want the number which is closest to 0.65, right? So you would just sample around the mean. So given I know the mean is 12.3, that's why I want to sample close to it. Because again, approximately, it will be about a half for that value. But again, you can't have a whole number. So it could be a half for 12 or 13, right? Because it's a discrete distribution. So I think it's going to be something around that. I don't know the answer, but it's going to be like 12 or 11. If I had to guess, it's about 12 or 11, which is why I would plug in those values and take the one closest to 0.65. That, I think, is going to do for now. Because, again, I know how to answer it, just don't have the correct tools to be able to. Right, number 5. Again, I'm reading the French one. 10 students are interviewed at random. Random variables, oh gosh. Okay, so we've got, and we're going to consider now, okay, so we've got all of these binomials and we're going to look at a sum of them. Now this is quite advanced. This is fully a question I would set my first year university students. So this is interesting. So S is equal to, in stats, of course, which I'll be teaching them tomorrow. Fun times. N1 plus N2 plus ... So we have a sample of 10 data points sampled from the binomial. So Ni belong to this same binomial. 0.615, right. Okay, so we're sampling from this binomial, and then we're going to add them together. Now, what does it want me to do? They all follow the same thing, great. And so you can define S like so, great. Calculate the expected value of S and the variance. Okay, so it's checking, do you know linearity of expectation? Which we do know, it is linear. So E of S, right, by linearity of expectation is actually just E of N1 plus ... plus E of N10. And this follows by linearity of expectation. And you can do this whenever your random variables, your sample, x1, n1 through to n10, I normally call them x, bilinear expectation, since the ni are what we call IID, identical independent variables, right? They're all sampled from the same distribution and they are independent. One student's mark should not have any impact on another student's mark. In theory, right, they could cheat and ruin the whole thing, but we would suppose you students would never cheat, would you? You would never do such a thing. Okay, so it's just adding them together, and one expectation, so E of S is just that, right? That's it. Yeah, so the expected value, so therefore, there's 10 of them, so E of S is just equal to 10 lots of, because they're all the same, the NP. And I worked out NP earlier to be 12.3. So I think then the answer is just 123. Okay, and then the variance. Now variance isn't quite linear. So the variance of S is the variance of all of the bits. Now, when I say variance isn't quite linear, if you've got the variance of like A times N, then it becomes A squared variance of N. So that's why it's not quite linear, because we have to square the coefficient. But all of these have 1 as their coefficient. So you just actually do just add. Like the variance of x plus y is the variance of x plus the variance of y. That's how it works. So by linearity, then this is just the variance of each one. n1 plus ... plus the variance of n10 by linearity of variance. And so where the variance of one of them, right, the variance of n1, for example, is for a binomial, it's npq. So it's n times p, where q is 1 minus p. So that is 12.3, which we know is np, times 1 minus 0.615. So that's 0.385. Yep, 0.385. That's one variance, and then we multiply by 10. So the total variance, so var of S, is 10 lots of that, equals 10 times the variance of n1, because you're adding it to itself 10 times. So I think the answer is 12.3 times 3.85. Right, so that's going to be like 40-ish variance. Probably sounds about right. I don't know, right? It's, again, plug into calculator. I'm pretty sure that should be your answer. And on to the final part of exercise 1. I feel like this is going okay. I don't think I'm well within the hour I have in theory to do all this question, depending on how this one goes. Right, consider a variable. M is S over 10. Right, so what we're doing there is we're averaging, right? We've just said in the previous one, we have added together all of the 10 scores, and now we're saying, right, and if we average them out, that's what we're doing here. Okay, so S over 10, yes. Now, what's the question? What does this random variable model? In the context of this exercise, this is modeling the average. This is, so there's that part A now within it, gosh. So M models the average test score of the class. So if there's 10 of them, then what we're doing is, or the sample mean, right, is what this is. So i.e., I'll write it in brackets, M is the sample mean. Right, so the sample mean says I've got 10 students, add them all up, divide by 10. That's exactly what we've done. Okay, B. Justify that E of M, ooh, giving me the answers from earlier, nice. So we have to show that E of M is 12.3 and variance of M is 0.47355, okay. Well, what I know though, we've worked out S, right? So what I would say is E of M is just, we know that M is S over 10, so sub that in. So that's S over 10. But then by linearity of expectation, we pull out 1 over 10th. So it's just 1 over 10 times E of S, right? Which is 12.3. Which is, I think I got 1, 2, 3 earlier. Yes! So it's exactly actually what so that verifies my earlier answer, which is nice. Yeah, so it's just that. And then the variance, you're going to divide by 100. So the variance is the variance of the same thing. And I said this for the earlier part of the question, preempted where it was going, because it's 1 over 10 squared. You have to square the coefficient when you pull it outside of the linearity of variance, times the var of s. So that's 1 over 100 times the answer I had earlier. I don't know what that is, but okay. So that is going to be 0.47355, which means I've got 47. I said it was about 40-ish. So this is 47.355. Has very helpfully there given me the answer to the earlier one without needing a calculator. I told you I was right. Never going to use a calculator, no matter what it does to my exam scores. You should all use a calculator, right? Are you even allowed? I'm going to assume you're allowed on this. L'usage de la calculatrice, okay, is with exam mode is authorized. There you go. Okay, so you're allowed it if you have it in exam mode. All right. I figured you would be, given some of these numbers. Okay, and I'm impressed with myself for knowing the French. C, maybe it's not as, I haven't forgotten as much of it as I thought. Right. Using the Bien-Aimé-Chebyshev inequality. I know Chebyshev's inequality, so I'm going to assume it's that. So Chebyshev, as we would write it, inequality. Again, was doing this in my first years, back in autumn term, Michaelmas, as we call it here. So it says that the probability of, oh man, it's like the expected, okay, it's like modulus of E of a value minus, oh no, it's like, wait, it's probability of your, what am I trying to show here? It's the probability of your thing minus its mean. Yeah. So I think it's the probability of your thing minus its mean. Sorry, but yeah, minus its expectation is bigger than, yeah, the probability that's bigger than some delta is smaller than, I want to say, the variance of x over delta squared. I think is Chebyshev. I will go with that, plug in the numbers and see if I get the answer they want, but I might want to modify that formula because I feel like there was an n dependence in there. I feel like the sample size had an effect. But anyway, I'll go with this for now. It's something like this. When you do no longer have to memorize formulas, right? Because when I'm doing questions with my students, I just look it up. You get quite bad at remembering them. So I should know Chebyshev's inequality, but nonetheless. So what does it want me to show? It wants me to show probability, the average grade of 10 randomly selected students. So we have done 10 randomly selected, is strictly between 10.3 and 14.3. So that's saying within 2. Right? Yes, so I think so using what I've just done, I think this is saying x minus 12.3 is bigger than 2, is less than or equal to the variance of whatever x is, divided by, so I don't think I mean x, I think I mean s, don't I? Or do I mean m? All right, I can call that one x, because I think that's true. But what am I subbing in? Now I've worked out what was 12.3 was m. So I think I want m. So I think I want m minus that, less than or equal to the variance of m, divided by delta squared, which is 4. So I think, i.e. delta is definitely 2 in Chebyshev. So we want, let me think about this now. Yeah, so it's saying the probability that a randomly selected student out of 10. So m equals s over 10. So that is indeed, right, which models the mean, which is the mean. Okay, So we're modeling the average mark, right? And it said probability of the average grade of 10 randomly selected. That's what that is. So M, yeah. This is why I'm thinking about what did we do in the previous step and how it's going to link in here. So we're taking 10 students' marks, adding them up and averaging them. So that's M. And so we know that M minus that probability that's greater than 2. So that says we're outside of that. So that should be is at least 80%. Okay, so probability we're outside of it, we want to be smaller than 0.2. So I think we want the probability of the randomly selected average mark, right? So the probability that it's, and this means, I'm going to just, for my own sanity, this means that M is outside. So the probability that it's outside of 10.3 and 14.3. So we want to be outside, well, this tells me probability of being outside of that. Yeah. Okay, I'm happy with that. Is then smaller than, now the variance of M we just worked out, right? What did I have to show it was 0.47355. 47355 over 4. Right. So the probability you're outside of that is smaller than 0.47 over 4 is almost, so it's definitely smaller than 0.12. So it is, let's just say that. So rather than doing an exact, I don't need this to be exact. So I can say it's definitely smaller, definitely true that the probability that M, I'm going to write it in words, that M is outside of 10.3, 14.3 is less than or equal to 0.12. Because that answer is smaller than 0.12. So the probability we're outside of that is definitely smaller than 0.12. So therefore, the probability that M belongs to in that set is greater than or equal to 0.88, which itself is bigger than 0.8, which is the 80%. So I think I can argue that, having used M as my variable in Chebyshev, and then we used the expectation and the variance. I had to pick delta to be 2 to get the right width that they wanted, and then it's just a case of approximating inequalities. But I'm pretty confident that feels like a sensible thing, and I'm supposed to be doing these quickly, so I guess we will move on and see what comes next. But that was it, right? Yes, exercise 2. Okay, pots A and B are independent. Alan owns a swimming pool which contains water. I must disinfect it with chlorine. Yes, you should do that, Alan. Don't be Alain, even, the French version. Okay, so something about concentrations. Chlorine decomposes. Yes, on certain days he takes measurements. Okay. Part A, study of a discrete model. Okay. Some stuff. We've got a nice recurrence relation. That's fun. Natural, right, natural. Ooh. Okay, so given that I am not expecting to do the entire exam, because again, I don't want to sit here for 4 hours. You all don't want to watch this for 4 hours. So I mentioned this at the beginning, right? Having seen how long it just took me to do question 1, right? I think I did a pretty good job. We'll see when I mark it, but it still took like a chunk of time. So I'm contemplating doing 2 or 3 questions here rather than all 4. And I've just noticed that there's a question about Python. Literally, there is a while loop written in the exam, which I will just say, love. Totally here for the fact that you are being tested on your ability to program and write code. Actually think that's great. However, I don't really want to write out a series of code to answer a question about swimming pool concentrations. So maybe I'll come back to it, but this is, having scrolled through now, I'm tempted to maybe not do question 2. I mean, we'll see, right? So question 3, there's a graph. It's asking me about derivatives. It's asking me about more derivatives. It's asking me minimum distances. Okay, more derivative. Okay, that feels like a question I can do. Feels like a maths question, actually, because the question 1 I've just done is just like, it's definitely maths, but it's just like pure statistics, right? We were doing probabilities, tree diagrams, and then a lot of statistical modeling. So question 2 looks like something to do with modeling, but also is asking me to do Python, which I don't really want to do. Question 3 looks like a maths question, right? It looks like calculus and geometry with the minimum distance bit at the end. And then 4, each of the following statements indicate whether it is true or false. Each answer must be justified. And it's telling me some points and about coplanar and projections. So that's geometry. Oh man. I mean, in theory, I should do all of the questions, and obviously that's what the exam is designed. But in the interests of making this a watchable video on YouTube, i.e. less than 2 hours, let's hope, maybe I'll put them in an order. I think I want to do 3 next. I want to try some pure maths. I'm going to skip out 2, and then maybe we'll do 4. We'll see how much energy I have left. But this looks like quite a fun exam. Anyway, TLDR version of that monologue. I'm going to move on to question 3. So, looks nice and mathsy, rather than doing code and chemistry concentrations. Not in the mood for that. Right. Here we go. Functions. Consider the function shown by the graph. Marvelous. Yes, we're told it's twice differentiable on -2 through to infinity. Okay. So we're looking here at a domain of -2 through to infinity. Cool. What else are we doing here? Something about... we've been shown its tangent, right? The curve is plotted below, and its tangent to the point B, yeah, is going through that point A, which is 0, -1. Okay, so I don't know what B is, do I? No, I'm going to probably have to work that out. But we do know... Oh, no, B is at X is -1. Okay, so B has X value -1, but we don't know Y, so let's just call it Y hat. A, I'm told, goes through 0, -1. Cool. That makes sense, and that all fits with the graph. And we have the tangent there. Okay. What am I doing? Using the graph to help respond to these questions. Okay, what is f of -1? Okay. So, based on the graph, I won't draw this one out, as I normally do, because I think I can just... because I need the actual scale here. So each box is 0.5, and we've got 1, 2, 3, 4 boxes. 4 boxes. So B is at -2. So -2. Okay, so the first question there is number 1. So f of -1 equals -2. Right, so I'm going to replace my y hat in there with a nice -2, because we know its value from the graph. And the derivative. Okay, so f prime of -1 is going to be equals the gradient of the tangent, which has been drawn for me. And we now know the 2 points. So the tangent is going from A to B. So let's kind of draw our little triangle, and we can say the gradient is going to be the change in y over the change in x. So y is going from -2 to -1. So that's a 1 change. And x goes from -1 through to 0. Right. Yes, so that's changing. Also in 1, yeah, it is changing in 1. So the gradient of the tangent, therefore, is just 1. Okay, cool, which is 1. So f prime -1 is just 1. Fabulous. What do we got next? The curve CF. Right, that's one on the graph, yes. Struggling with the translation is convex. Is it convex on its domain of definition? So it's not, is it? Because it's got a funky shape like that. Right, it's kind of got something like that. So I'm trying to remember my definitions, but I think this bit is convex. Right, and this bit here is concave. So it is definitely right, and there's some division between them. So it is not. Is that all I have to say? Is it justify your answer? Okay, fine. So I would say function is convex only for e.g. -1 to some point. What have I got it on the graph? We go to 1, I assume. I can only really say up to 0.4 because then it disappears off the page. So I'm going to say to 0.4, which where the upper limit for x in that range, the upper limit is due to edge of graph, because I don't know what's happening when I go off the page, right? I mean, we have an idea. It's probably going to continue, but we don't know that. And lower limit is due to concavity, sorry, due to concave, as x goes to -2. Yes, as we get closer to -2, it has that kind of change, right? It's kind of like a point of inflection in the middle, is what this feels like. Sort of like a, right, so I think B basically is a point of inflection, right? Because we're seeing that kind of wiggle shape, so B is a point of inflection. All right, I think that is enough convincing. Right, part 3. Where are you? Conjecture the number of solutions to the equation. What's the equation? Oh, fx equals 0. Okay. I mean, based on the graph, so fx equals 0, solutions, so that corresponds to when it crosses the x-axis. Solutions correspond to when the curve, which is called c subscript f, crosses the x-axis. I can only see 1. I can see 1 on the graph. So I will conjecture there is just 1. So likely 1 in total. Assuming, I'll write in brackets, assuming behavior continues as shown. Right, so I think I'll draw this in red just to stress what I mean here. So I think, right, we've got part of a graph, but I think the idea, if I've understood the question, is it's going to kind of continue. It's going to look like almost like an x cubed. It's going to keep growing, I think. Otherwise, right, why are they zooming in on this part? So I think if we can assume that that general shape is going to continue, then we're only going to have the one crossing point, which is the one shown there, and it's between 0 and 0.2. So I think the root between 0 and 0.2. All right, is that it? Number of solutions, give a rounded value, to 10 minus 1, close to a solution. So I'm going to say 0.1 based on the picture. I'm going to say x equals 0.1 because it's crossing very close to the middle, right, based on graph, which is to scale, right? So it's about halfway between 0 and 0.2, approximately. So should be that. Cool, is that it? No, obviously not. Part B, study of the function. Okay, so consider a function f. Okay, so this is now our function, right? And it's given by, we've been told what it is. Okay, so we're going back. So this is now B part 1, I guess. Weird numbering lettering system. So B part 1, we are now given the function. So f of x is x squared plus 2x minus 1 plus the natural log of x plus 2. Okay. Right, so straight away, before I even look at the question, I can see why this is only defined at minus 2, right? So the log term here, this is the problem. So this is going to tend to minus infinity as x goes to minus 2. So that's the problem. So actually, this is going to be at minus 2. Right, it's going to be an asymptote. Right, so this is x is minus 2, and this is now an asymptote. Okay. but the other one will keep increasing. Cool. Given this is, I don't know why we didn't start with the equation, but anyway. Determine by calculating the limit of the function O as f goes to -2. Okay, so I just need to know what happens for the quadratic. So x squared plus 2x minus 1 evaluated at x is -2 equals -2 squared is 4, -4 minus 1, so equals -1. So the first bit, so therefore f tends to -1 plus infinity, no, minus infinity, sorry, from the log. So it's just going to minus infinity, isn't it? Yeah, right, obviously the -1 doesn't make a difference. Tends to minus infinity as x goes to -2. Right, because the log is going to blow up negative infinity of the log as you go to 0. Awesome. Interpret the graph, what? Translate it. Interpret this result graphically. Okay, so that means, as I've shown on my redrawn version, there's that one. So we have a vertical asymptote at x equals -2. Right, so it's plummeting down, it can't go through that point. Great, which is why it's defined on that region. Marvelous. And then, what does it say now? We assume that the limit is plus infinity, the other way. Perfect. Okay, 2. What do you want me to do now? Show that for all x bigger than -2, f prime is that. I can differentiate. So f prime of x is 2x plus 2. So that's differentiating the function. And then the -1 goes to 0, and then the log becomes +1 over x plus 2. Okay, so if I'm going to put that over a common denominator, that becomes x plus 2 times 2x plus 2 plus 1 all over x plus 2. So then expanding that out, I'm going to get 2x squared plus 2x plus another 4, so plus 6x plus 4 plus 5 over x plus 2. And hopefully that's what they wanted. 2x squared plus 6x plus 5. Amazing, that was easy. Great. Okay, easy for me. I'm going to differentiate. But it was testing that, right? Can I differentiate? Awesome. And x is still bigger than -2 because, of course, we cannot divide by 0. That would be bad. Okay, study the variations of the function between -2 and infinity and draw up a complete table of variations. What does that mean, Franz? Study the variations of the function. Étudier les variations de la fonction. Sir, -2 to infinity. Right, so study the variations of the function from -2 to infinity. Weird opposite way to point the brackets, but okay. And draw up a table of variations, a complete table of variations. I don't know what a table of variations is. So what does it want me to do? For f. What am I trying to figure out here then? I mean, I know what the function looks like, don't I? Let me draw. I have no idea what a table of variations is. So let me just think about what I do know, right? So there's an asymptote at -2. I'm going to sketch it. Let's just kind of sketch what we know and figure it out here. So there's an asymptote there, and then it's got like a wiggle in the middle, right? It's kind of doing that, and then it's going up, and it's doing that, and it's going like that. Okay, right, and that's approximately what we're seeing there. Yeah, shooting up. So what do I know? I know that this is a vertical asymptote at x equals -2. I'm pretty sure there's a point of inflection at b, and b was, it was -1 -2 is the point of inflection. A was the point -1, 0. Right, so it's just -1 there. And then we've got this root here, so this was like 0.2, and this is like our root, which is close to 0.1-ish. Okay. Fine. So I don't know, let's call that x star. So root f of x star equals 0. And then what we're seeing up here is this tends to infinity as, so f tends to infinity as x goes to infinity. I mean, to me that's a table of variations, but I don't, there's probably a little bit of theory I'm missing. I don't, right? We've got the graph, I've explained hopefully all of the points, all of the intersections. I've got, I guess I could do gradient changes then. So if I had a different color. Is the only other thing I could maybe is helpful. Because I've just calculated, okay. I've just calculated the gradient. So maybe I'll add that here. So what do we know? We know that the gradient, oh gosh. Okay. Maybe let's look at, oh gosh, this is a thick pen. Let's change that. Let's look at the changes in f prime. Okay. Right. So we've got the f prime is this quadratic. So 2x squared plus 6x plus 5 over x plus 2. Right. So it's got a positive gradient, and then it kind of goes flat, and then it kind of maintains a positive gradient. So I think that's always positive, except it goes, does it go through 0 at, okay, so let's see, at x equals -1, f prime is 2 plus 5, f prime is, we worked it out, didn't we? We said it was -1. Yeah, it was -1, so it doesn't go flat. Not -1, +1. I worked that one out earlier. Okay, so it doesn't change sign. So the gradient is always positive, right? So this is greater than 0 for x belonging to -2 to infinity. You can see in the graph, always a positive gradient. But we are seeing, okay, the only thing we are seeing then is that if I add this here, okay, so maybe this is what it means. This bit is concave and this bit is convex. So there is a switch there. I'm going to leave it at that because I don't know what they want. Feels like I've written sensible things. Number 4, show that the equation admits a unique solution. Alpha between -2 and infinity, and give it, gosh, to 2 decimal places. Okay. Right. I'm having to think about this. So, B4, okay. So show that it has a unique solution, call it alpha. All right, well, we say f, okay, so f is negative for x less than alpha. Oh, I can show the derivative is not 0. Yeah, we know the derivative is, okay, I got it now. And f is positive for x bigger than alpha. So we have a unique solution provided no more turning points. Right, I can show the derivative doesn't hit 0. Okay, solution provided no more turning points. Okay. I mean, we can kind of see it from the graph, but anyway, let's just check that there are no more turning points. So, f prime is 0 when, right, it's no more turning points which occur when f prime is 0. Okay. So, when is f prime 0? It's when the quadratic is 0. So when 2x squared plus 6x plus 5 equals 0. So, quadratic formula. So that tells me that x is equal to minus b, minus 6 plus 1 minus the square root of b squared minus 4 times a times c. Okay, wait. B squared minus 4 times a times c divided by 2a. Right. Yes. Okay, cool. So it's imaginary. Amazing. So you just say, so x is minus 3 over 2 plus or minus, because that's 36 minus 40. So it's the square root of minus 4, which is 2i. So is I over 2. Right. So i.e. complex. So therefore, f prime is actually strictly positive because it's never 0. F prime is strictly greater than 0 always. So no turning points. Turning points. Right, so just to explain this to all of you, so you know that my thought process, let's say, and I'm not making this up. So the idea here, right, is if you look at our graph, we've got this function like with the wiggle. We can see it crosses the x-axis, so we know that there is a root. Now above the x-axis, it continues to increase. Now the only way another root can occur is if after that increase, it comes back down. So there has to be a turning point. There has to be a point where the derivative is 0. There isn't. We've shown that. And then below the axis, it could turn back up, but to turn back up, there has to be a point where the derivative is 0. So I have just shown the derivative is never 0, so therefore there are no turning points. So that means once it's crossed through the axis, it can't turn around either above or below to come back through it. So that to me is my argument, therefore, that there is only a single root. Great, so no turning points, therefore single root, which implies unique root. Now, how do I find that root? I need to solve this being 0. How do I solve this implicit expression? Okay, so the expression for alpha then is what? So expression for alpha is when f is 0. So it's f of alpha must be 0. So that means now from the equation, that means alpha squared plus 2 alpha minus 1 plus log of 2 plus alpha equals 0. So I want to basically argue, oh, but I know alpha's small, I'm going to use a log expansion. Okay, so I'm going to try, I think that'll work. Right, nice. So what I'm going to say is since, again, I don't know if you're going to use a log power series in your baccalaureate course, but it's what I'm going with. That's why it's annoying. Okay, so I'm going to say since alpha is small, which it is, we can approximate the log. So the way it works here, ln, and the way the log works is that the log of 1 plus x is approximately x. So here, I can say the log of 1 plus alpha is approximately 1 plus alpha. Right, so I'm setting my x to be 1 plus alpha. Oh, but that's not small anymore. Thought I had it then, but that's not going to be small anymore, is it? Fine. I thought I had such a smooth way in. Okay, that doesn't work because 1 plus alpha needs to be small. 1 plus alpha is not small, that's like 1.1, that doesn't work. Okay, doesn't work. I'll just write cross. Contradiction doesn't work. Damn it. Okay. I was hoping that was going to help me, but it's not. So I am going to now use something I learned very recently when doing the A-level exam for the second time, the Newton-Raphson process. So if I remember what that was, I'm thinking here, we know f and we know f prime, so can I use that? That is a root finding method. So I think maybe if I use Newton-Raphson, so I'm pretty sure Newton-Raphson says, can I remember it? Gosh, it was like saying f of x is basically equal to f of some root that we want, yes, plus x times f prime of alpha, but it's not x, it's x minus alpha, isn't it? Yes, plus x minus alpha times f prime of alpha plus dot dot dot. So I want to go from there. Oh man, but do I want to use, so if alpha is 0, wait, so if I set alpha equals 0 in my formula, I can say f of x is f of 0 plus x times f prime of 0. Okay, so x therefore, okay, so now got it. So now let x equal alpha, which is the root we want. Right, okay. So I'm trying to rederive this. So I don't mean alpha here, let's call it alpha hat. This is like a fixed value that I can pick, right? Some point for my graph, that's gonna be like my first guess. Right, but then I set x to be alpha, so then I can say 0 equals f of alpha, which is the root, so that's f of 0 plus x times f prime of 0. But x is alpha. So that means that alpha is just minus f of 0 over f prime of 0. Okay. And then you repeat and iterate. So, and then iterate. So I reckon, I'm not sure if this, I bet this is not how you're meant to do it, but this is fresh in my mind from A-levels. So I think I can now work out these things. So I think alpha, let's say 1, right? The first guess is going to be minus f of 0. Now, f of 0 is, I think I've got that point, haven't I? Yes, it's the value at a, which is minus 1. So it's minus 1 over the derivative at 0, which we haven't worked out, but I got the formula for the derivative to be that. So, gosh, so that's, what is that? It's 2 lots of minus 1 squared is 1, plus, no, minus 6 plus 5, divided by, no, it's f of 0, sorry, being an idiot. I do know what that is, that's actually quite easy. Doing it for minus 1 for some reason, right? I know what f prime of 0 is, because I've got the formula. So it's just 5 over 2. So I'm saying, therefore, so then this is equal to 1 divided by 5 over 2, so it's 2/5. Which is a terrible estimate, but it's an answer. So if I think alpha 1, okay, so if alpha 1 is 0.4, then I can say alpha 2, an improved estimate. Okay, and then this would then work, but I already think it's 0.1 from my earlier guess. So I reckon, okay, I'll just say etc. But now I'm going to say instead use Newton-Raphson, right, for, and we're trying to find the root. Yes, so that should just work, right? No, it should be my old one minus that. What have I done here? I've done something wrong here. Okay, hang on. So go back up here. I want a specific root. Yes. So I think I like subtracted off. So what I want to say is it's f of x minus alpha. No, it's f of x. Okay, so the thing I want then is f of, but what is f of x? I don't want f of x. I know what it's going to be. Oh man, if only I remembered Newton-Raphson. Okay, let me just try that again. So I think what I want to say here, let's be clear about this. I'm trying to work out x. Okay. So let's just get an equation for x. So let's just get an equation for x. And then we'll worry about what f of x is. Okay. So what I'm trying to say is x minus alpha hat times f prime of alpha hat. So I'm trying to say that that is actually equal to f of x minus f of alpha hat. Okay. That makes sense. Yes. Fine. Now I say, so therefore, so alpha hat minus x, therefore, is equal to f of alpha hat minus f of x divided by f prime of alpha hat. So that tells me then, now I'm trying to work out x. Oh, I've done it wrong. No, let's not do that. So it's alpha minus x. Keep them the right way round. x minus alpha hat is that. So I'm saying that x then is equal to alpha hat plus f of x minus f of alpha hat over f prime of alpha hat. Right. Okay. Now I want to find the root f of x, don't I? So this says, right, and so if x is the root of f of x is naught. So I think then the next root to try, so that's x is the previous alpha minus its previous value over its derivative. Now that looks like Newton-Raphson. That I think is Newton-Raphson. So I want to say use Newton-Raphson when alpha hat is my first guess of 0.1. Right, so if I sub that in, so that says my new guess for it, which I'm calling x, is the old guess minus f of 0.1 divided by the derivative at 0.1. Right, so I think it's 0.1 minus the value of f at 0.1. So I've got a formula. So let's just work out that. So 0.1 squared plus 0.2 minus 1 plus log of 2.1. Okay, so I don't know what log of 2.1 is, but anyway, divided by f prime of 0.1. So f prime is divided by 2 lots of 0.1 squared plus 0.6 plus 5, all divided by x plus 2, 2.1. So I reckon this is going to give me a more accurate answer to the problem. So I think what this is sort of saying is, i.e. alpha, let's call it alpha 2, the improved guess is the old one, and then we want to do minus, and then we got a whole thing. So it's log of 2.1, whatever that is, annoying. Log of 2.1. Okay, and then it's now minus 0.8, but then take away 0.11. No, 121. 0.1 squared is 0.121. So it's 11. No, it's 10 squared. It's 0. What am I doing? 0.1 times 0.1 is not that. It's 0.01. Yeah, it is. 1/10 squared is 1/100th. Yes. So it's 0.8 minus 0.8 minus 0.79. So it's that minus 0.79 divided by, gosh, 5.61 over 2.1. 5.61 over 2.1. So I reckon if I put that into a calculator, that's going to give me a better approximation for alpha. I'm going to leave it there, but I think there is a way to use Newton-Raphson process, this way of estimating roots, finding roots, where, again, I think the initial input is the thing that I found in the earlier question. So I think that's actually how you do it. I was trying to sub in 0 as the first guess, but eventually we would get to something like this, but I think this is going to be more accurate. So very much needing to move on. Right, so that was 4, so let's go to B5. It's quite good, this. I like this. This has got a lot of different things happening. Deduce the sign of f of x between -2 and infinity. Deduce the sign of f of x on -2 to infinity. I mean, I've got it from the graph. This is very, very odd. So we know it's a root. Okay, so until alpha, right. So what can we say? We've got like we've got -2, we've got 0, we've got alpha, and then we've got plus going to infinity. So f of x, here it is negative. It's also negative here. It then switches here to become positive, and then it goes all the way. I mean, is that it? Deduce the sign? Yeah, I'm going with that. So it's negative up to alpha, positive beyond. And then show that the function admits a single inflection point and determine its x coordinate. Okay. So there's a single inflection point. Right. As it's to do with second derivative, isn't it? So the point of inflection is, so again, I've recently done an exam from Scotland and I learnt this. The point of inflection is where there's a change from convex to concave. Now I'm pretty sure that that occurs at the point B. So I think, I'm just going to write this is not my answer because I'm going to have to prove it, but I think the point of inflection is at B. I've written that several times in the question. But to prove it, but I can show this by considering f double prime. Because the idea is, right, and I've now learnt this from the Scotland exam, the idea of point of inflection is that your second derivative changes sign by considering f double prime and where it changes sign. So I think if I compute that, I can argue that it occurs at B, and B is of course the point I worked out a while ago, which was, we had to work it out, it was -1 minus 2. Okay, so I'm pretty sure it's the x coordinate -1, but let's check. So f double prime, let's do some more differentiation of this function. So it's a quotient, but I always use the product rule, so I'm going to do that. So I'm going to differentiate the top and get 4x plus 6, and then leave the bottom alone. Or I can differentiate the bottom, so that brings out a -1, and then I get the thing over that thing squared. There's no chain rule, it's just a single x, and I have the full quadratic on top. So 2x squared plus 6x plus 5. Right, so if I were to simplify f double prime over the same denominator, that's 4x plus 2 times x plus 2. Then I'll take away all of this, 2x squared plus 6x plus 5 divided by, so it's divided by something squared. So the sign is going to be entirely determined by the numerator, the part on top. So f double prime now is going to give me 4x squared plus 8x plus another 2x plus 4. And then I'm going to take away 2x squared, take away 6x, take away 5 over x plus 2 squared. So it's going to be, I think I've got 2x squared, I've got plus 10x, so I end up with plus 4x, and I've got plus 4 minus 5, so -1 over x plus 2 squared. So the sign of f double prime is determined by the sign of the quadratic. Okay, sign of quadratic. So, which is 2x squared plus 4x minus 1. Now, look for the roots. So this has roots at x equals minus b minus 4 plus or minus the square root of b squared minus 4 times a times c divided by 2a. So -1 plus or minus 16 plus or minus root 24. Oh gosh. Maybe this is not the point of inflection I was hoping for. Okay, interesting. And it's root 24 and it's divided by 4. Should have the quarter out there. Okay, so that's -1. I can't bring out the 4. Root 24 is, gosh, what goes into 24? 4 times 6. So I'm bring out a 2 plus or minus a half root 6. Okay. Yes. Okay. Is that right? I'm getting 10 minus 6x. That's okay. That's okay. 4 minus the 5. Yeah, that looks okay. Oh, no. I'm talking not... Written the wrong number. Glad I checked that because it seemed odd, right? So I'm an idiot. It's 4x plus 6. Copied the wrong thing down. Okay, so it's 4x squared plus 8x plus another 6x and then plus 12. So it's going to be a different answer, isn't it? So it's 14 minus 6, so it's plus 8x. And then it's plus 12 minus 5, so it's now plus 7. Oh gosh, it's going to be a weirder answer, not helpful. Unless... No, that's not going to work. Oh man. Okay, fine. So I think that's my quadratic, 2x squared plus 8x plus 7, right? Because it's definitely plus 12 minus 5, yeah. Plus 8x plus 7. So it's now minus 8 plus or minus 64. If we do that bit here. So minus 8 plus or minus b squared, 64, minus 4 times a times c, all over that. Okay, so x is minus 2 plus or minus the square root of 64 minus 56. Yes, right. 4 times 2 is 8. 8 times 7 is 56. So it gives me an 8 over 4. No, not. 4 is only on the square root. Do this properly. So that's x equals minus 2 plus or minus, that's 2 root 2, so plus or minus a half root 2. Okay. Minus 2 plus root 2 over 2 is the point where it changes, second derivative changes, okay. Okay. Got it now. Whew. Okay, this makes sense. Okay, so the negative root, so x minus, which is minus 2 minus a half root 2, is outside of the domain. Right, so that is, right, it's definitely, it's less than minus 2. So the negative root, so when, there's a lot happening, so let me just kind of go through my thought process. I've calculated the second derivative. I'm looking for when it is 0, as those points will tell me when it changes sign, right? Because it will, as it crosses through 0, it has to flip sign. That's how it works when it's a root. Now, I found the two roots. One of them occurs for x less than minus 2. So one of them's like outside of the domain. So who cares about that sign change? However, the other one, which is given by x plus is equal to minus 2 plus a half root 2, which is like minus 1.3-ish. That bit. So this bit is inside domain. So this is the point of inflection, because beyond that, I know it's concave. Concave means the derivative is increasing. Okay, so I'm going to call this x plus. So if x is less than x plus, we know it's concave. Sorry, concave. Because the gradient is increasing there. Oh man, what's happening? Yeah? I think it's concave there. Because the gradient is increasing. Both cases, the gradient is increasing. Okay, I think it's concave, and then for x greater than x plus, it's convex, right? So what is f double prime? Is it positive or negative? So f double prime, so I'm just trying to get fix on signs. So f double prime of 0, which is definitely where I think it's the it's like far to the right. It's to the right of the root. So f double prime of 0 is equal to 7 over 4, right? So it's positive. Okay, so it switches sign and goes negative at that point. Gotcha, right. So if I'm to plot this on a number line, right, then we say, so you've got minus 2, then you've got, and this is going up to infinity if we want, we've got 0, and we've got alpha. And then we've got this other point, which is minus 2 plus root 2 over 2. Okay, so here, f double prime is negative, and then all the way through here, f double prime is positive. So I think the point of inflection, which is what I had to do, right? Yes. So therefore, the inflection point is at that point, at x equals minus 2 plus root 2 over 2, and that's all I had to do. And that better be it. Oh no, of course, there's a part C. Of course there's a part C. So, what are they going to have me finish with? Distance minimal, the minimum distance, right. So we got a function, g of x, which is given by log of x plus 2. Okay. Now we got the curve, great, representative on some orthonormal coordinates, I and j, right, x and y axes, cool. Something about m is the x coordinate of this, yes, great, and j is the y coordinate. Yes. Okay, and we're trying to minimize the distance, right? I'm just translating all of this. Bad translation plus French. Okay, so I want to work the minimum value of the distance. Okay, cool. Fine. Okay, and we're defining the, okay, so we're finding the distance to be, we're claiming the distance is h of x equals, right? We consider the function defined that way. Okay, so we want, so let's not, it's not that. We want the minimum distance, but we're considering the function h of x, which is j times m squared, where j is the y coordinate and m is the x coordinate. Okay, fine. Justify something. Justify that for all x greater than minus 2, okay, h is given by this. Okay, where h is j times m squared. Right, so if I have a picture, just think about this now. So I've got a picture, I've got some point here. It doesn't matter about the graph, I just have a point. I know what? I know that the x value here is m, right? So this is just x equals m. And then this up here is y equals j. Okay, great. And so we want to know this distance, don't we? And I know that this point is something. But we know that that's h of m. No, the graph, right, great. So we know that is therefore at g of m. Fabulous, right. So what we know then is it's Pythagoras' theorem. So we've got a triangle here. Nope, not whatever that is. Triangle here, where the horizontal distance we know is m. We know the vertical distance is j minus g of m. And we want to know this. Right? Is that what we're arguing? We're not exactly arguing that, but that is a triangle. We want to work out j times m squared. I don't know. Oh, that's jm. Oh, it's that thing squared. Okay, not j times m squared. Bad notation, French baccalaureate. It's the, okay, so I think what it means is it's this like length squared, right? And that's what we're trying to minimize, right? So i.e. want to minimize, right? Gosh, so we want to minimize h, fine. Because h represents the distance. Got it, makes more sense now. So this is h. So I can just say, well, h of x then is just by Pythagoras. H of x squared is, which is what we want. Yeah, that's h. So h squared equals j minus g of m squared plus m squared. Now m is just given by x. So since m is some value x, since m equals x, and g of x is log of x plus 2, then we've got what we need. That implies h of x squared, which I think is what we wanted, right? No, h is the thing. Okay, fine. H is the thing. So that's actually root h. Okay, cool. So h is that. H is that. So it's j minus g of m. Now j is an unknown value. What am I trying to show it's equal to? Something. Okay. With ones in. Don't want that. Oh, j is at 1. Okay, great. J is at 1, right? So y equals j, which is 1. Phew. So j is at 1. So it's just 1 minus g of x, all squared, plus x squared, which is then substituting in for g of x. That's then 1 minus log of x plus 2 squared plus x squared. And I'm pretty sure that should be what I want, but let's just check, bracket, log of x plus 2 squared minus 1 plus x squared. Yes, so I can just say, which is the same as log of x plus 2 minus 1 all squared plus x squared. Because you're squaring it, so you can multiply through by minus 1, doesn't matter. Ooh, okay, good. That was C1, so now let's do C3, 2, 3, 2, C2, C2. Lost track, C2. Okay, translation. The function is differentiable, and we note its derivative function. Have you given me that? Yes. Okay, great. Or something is the function studied in B. Oh, where f is the function we studied earlier. Fabulous. So we're saying h prime of x, okay, is 2f of x over x plus 2, where f equals the thing we had earlier. It's going to get complicated, isn't it? 2x squared plus 6x plus 5 over x plus 2. I know that was f prime. It's not that, Thomas. It's the actual function is x squared plus 2x minus 1 plus log x plus 2. All right. So h prime is some mess. Fine. Why are we doing this? Oh, not another table of variations. Draw up the table of variations of h between minus 2 and infinity. Okay. Of h or h prime? Of h. Okay. And we know what's happening to its derivative. Right. So we know that, okay, what do I know about f? Let's start there. So f of alpha equals 0 is a unique root. So, which implies that h prime equals 0 at exactly 1 point, which is x equals alpha. Okay. So therefore h has a turning point at x equals alpha. Okay, I see where they're going with this. So we've got the derivative of h, formula for h prime. We've expressed it in terms of f, which is our earlier function. We know that f only has a single point where it's 0, which means h prime has a single point when it is 0, which means h has a single turning point. Since h is the distance, so you say now, since h is the distance, the turning point must be a minimum. Because if I'm measuring a distance, I can obviously take a maximum by going further and further away. It doesn't make sense to have a maximum distance for the picture and what has been drawn, which is what we're figuring out. So h has a minimum. The turning point is a minimum. Okay. So we can see then that h is always positive, sure, but I don't know what a table of variations is. So I guess I can draw h prime along the number line and say, so that's going up to infinity, this is minus 2, and then we know we go through 0, and then we have alpha. So we know that, okay, so we know that h prime, all right, when x is 0, what is f of 0? F of 0 is minus 1, okay. So when x, let's do that for a minute. When x is 0, f of 0 is minus 1, right? We had that one earlier. F of 0 is indeed minus 1, yes, great. So h prime at 0. So I'm just trying to work out one of the signs and then I know it flips. So h prime of 0 is equal to minus 2 over 2, which equals minus 1. So it's negative here. So I can say here that h prime is negative, and then here h prime is positive. Right. So h prime, yes. Okay, gotcha. H prime is positive. So h prime is negative there and positive there, and it's 0 there. So if the rate of change of h, so that means there's a rate of change of h like that. Cool. Okay, is that all I need to do? I think that's all we need to do. So h prime, i.e. h decreasing, decreasing for x belonging to -2 to alpha, and then it's increasing. Yeah, good. So we can see it's clearly a minimum, right? Good, for x belonging to alpha to infinity. So therefore, x equals alpha is the minimum distance. Marvelous. So is that all I had to do? What does it say now? And deduce the value of x for which the distance is minimized is alpha, where alpha is the bit from earlier. Yeah, exactly what I've done. Okay, amazing. Right, so then let's do part 3, the last bit of this one. Probably taking too long on this, but anyway, we're going to finish it off properly. Okay, so now we have this point alpha. Marvelous. Show that this is true. Okay, so we want to show, so we have to show that log of alpha plus 2 must equal 1 minus 2 alpha minus alpha squared. So, well, that's easy. Okay, so at x equals alpha, f equals 0, f of alpha is given by the formula we had earlier, right? So it's just that I'm rearranging. It's given by alpha squared plus 2x minus 1 plus log of alpha plus 2. So therefore, and that's 0. So therefore, it is true that log of alpha plus 2 must be 1 minus 2 alpha minus alpha squared. Just rearranging that equation. Marvelous. Are we done yet? Come on. Dragging. 3b, last bit. Deduce that the tangent to this point and the right are perpendicular. Okay. Gonna have to think about that one. So I'm going to draw my graph. Okay, I'm going to draw out the graph and something happening here. So we've got, what have we got? We have a distance function, right? And we've got a function doing that, and this is g of x. We've got the point 1. From that point we have m, which is the minimum distance, and we know this occurs at x equals alpha. Okay, great. Okay, I'm happy with that. And then this is what this curve is c of g. Right, and then we've been told that the tangent at the point alpha, okay, and the right jm. So we're trying to argue that this is a right angle. So I've drawn a terrible picture. We're trying to argue, to make my picture more realistic. I see. So we're trying to argue that this, if I were to draw it more accurately, we want to show that that is a right angle. Okay. So the question wants me to show, and this is y equals 1, that is a right angle, and that is m alpha. Right, so what do we know at alpha? Okay, so at alpha, we know that log of alpha plus 2 equals 1 minus 2 alpha minus alpha squared. We know that h prime, which is the distance, is a minimum. So we know that h prime of alpha equals 0, which implies f of alpha equals 0, which actually just implies that formula. Okay. Then what else do we know? The tangent there. So g of x is log of x plus 2. So the derivative, so g prime at alpha is 1 over log of alpha plus 2. Fine. And the gradient of the straight line, got it, right. So I've got the gradient of the curve, and then I can work out the gradient of straight line and show the product is -1, right? And then the gradient gosh, a lot of stuff being tested here. A lot of geometry, actually. Don't even need question 4. This is all geometry with calculus. The gradient of J M alpha is... okay, the gradient of that is what? So it's a straight line. So it's the change in y, which is 1 minus g of, no, the change, so it's a straight line, which has some change in gradient. Hang on, I have to think about this. So close. The change in y, but it's not perfectly changing in y though, is it? But it's this line here. Yeah, okay. So it has a negative gradient, right, it's fine. It's the change in y, delta y over delta x. Okay, yeah, is, okay, it's the blue delta y over delta x, which is going to be negative. So the change in y is 1 minus g of alpha. That's the total height difference from that, yep. 1 minus g of alpha. Okay, and the change in x is alpha. And the point is 1 minus g of alpha would be positive, so I need a negative answer, so it's minus that. Okay, so I reckon, so then the product of gradients is, is g prime of alpha times g of alpha minus 1 over alpha, which is hopefully minus 1. G prime of alpha is 1 over log of alpha plus 2. G of alpha is log of alpha plus 2 minus 1, all divided by alpha. Oh man, so this is actually just, which equals 1 over alpha minus 1 over alpha log of alpha plus 2. Okay. This doesn't look like it's going to be minus 1. This is really, maybe it does. Okay. So want to show this product is minus 1. Okay, now what is it? So it's 1 over alpha minus 1 over alpha times 1 over the log. The log we've been given is this thing, 1 minus 2 alpha minus alpha squared. Okay, so this is now 1 over alpha times 1 minus 1 over 1 minus 2 alpha minus alpha squared. Gosh, which is 1 over alpha times 1 minus 2 alpha minus alpha squared minus 1 over 1 minus 2 alpha minus alpha squared. This does not look promising. Which is 1 over alpha times, so we lose the 1, minus 2 alpha minus alpha squared over 1 minus 2 alpha minus alpha squared. That's not what I wanted. Something's gone wrong. So I was hoping this would be minus 1. It very clearly is not minus 1. So what have I done wrong, right? So the issue here is, what is the issue? So when I'm doing the product, I'm pretty sure, okay, I think this is correct, right? Because what I'm saying is we've got the gradient of the curve, which is g prime of alpha, like that's true. And then we've got the gradient of the straight line, and that's definitely the change in y, yep, over the change in x. So I think that is correct. Now, are those two correct? So g is log of x plus 2, which means g prime does not involve a log. There it is. I make the mistake so you don't have to. Right, it's 1 over alpha plus 2. So that's going to simplify things drastically, because now this is all nonsense, right? Let's get rid of this. I want to show the product is minus 1, and I think this is going to work now, because I was silly and differentiated a log to give me 1 over a log, which of course Well done if you spotted that live, by the way. So actually fixing it now, right, I think this is gonna work. Because now you sub for the log, right? Because I didn't want a log in there, that's what was annoying me. So it's that times, now the log we had earlier was 1 minus 2 alpha, 1 minus 2 alpha minus alpha squared, minus 1 over alpha. Right, that looks more like it. So it's 1 over alpha plus 2 times, what we've got on the top is a minus, and then we've got an alpha times 2 plus alpha, all divided by alpha. Amazing. So the alphas cancel, the 2 plus alpha cancels, equals minus 1. Therefore, perpendicular. And I hope the end. Please tell me the end. And the end of exercise 3. Now, as I mentioned earlier, exercise 4 is asking whether the following statements are true or false, where you, of course, must justify your answer. And it seems to be talking about various points in 3D space, and it's asking whether they are defining a plane, whether they are coplanar, whether the straight lines intersect, and whether they are an orthogonal projection. And in each case, it's giving you a collection of those points. Now, this is just geometry, right? This is, do you know the equation for a plane? So that would be r dot n equals constant. That's how I would think about it. So you would kind of use that to check whether those points are in the plane, talking about intersection of lines. And then at the end, it's talking about orthogonal. So that would be if the line from the point to the plane was perpendicular to the plane, then it would be an orthogonal projection. So I could obviously go through and do that. At this point in the video though, right, I don't want this to last forever. I feel like I at least have an understanding of what question 4 is asking me to do. It's just going to take me a while. It's going to take me 5 to 10 minutes to write out the equations and check whether or not these conditions are satisfied. So I've also skipped question 2 because it involved Python coding, which again, I don't really want to do. But I think at this point, I'm going to call it, in the sense that I've done 2 pretty involved questions, right? We are a good chunk of time into the 4 hours. I think I'm still very much ahead of time, given I've done 11 marks so far. I think I've done 11. I did, question 1 was 5 points and question 3 was 6 points. So I have answered 11 marks out of the 20. So I'm more than halfway through. I've definitely not yet used half of my time. However, as I said at the very beginning, I saw that this exam was 4 hours and I was tempted to say that means I can't do it because it's just going to be way too long and it's going to be boring and no one's going to want to watch me do maths for 4 hours on YouTube. So I still stand by that. I think 4 hours is too much. I think I would get exhausted. And you know, that's part of the battle for all of you poor students doing this, right? 4 hours is very, very intense to do an exam for 4 hours. But I think I have answered a nice question on statistics and probability and got a feel for that, let's say, applied element of the Baccalauréat General. And then I've just done that question which involved graph sketching, calculus. There was some geometry as well. So I feel like going through and doing question 4 would just be more geometry. And I've just done a whole lot of geometry. So I think I am in a position now to judge the level of this exam and compare it to all the others. But before I do that, before I place the French Baccalauréat General on my tier list, we do of course need to mark the exam, which we'll do in just a moment. I say we will now mark the exam, which is proving to be more difficult than I first realised. So I'm struggling to find an actual official mark scheme. And I have been in touch with a former student of mine who did study in France, and they did mention that often official mark schemes do not exist. So, in a slight deviation from my usual way of using the official mark scheme, I do not have the official mark scheme. However, I have found a French website, Le Figaro Étudiant, where they post the past baccalaureate exams along with solutions. Now, I did manage to find the paper that I have taken, and they have posted solutions, which I believe come from a French maths professor who has written out, I guess, their version of the solutions. Now, given this is posted online and comes from an actual professor of mathematics in France, I am going to take this as the official mark scheme and at least compare my answers to the professor's answers, and let's see whether or not I managed to get the 11 out of 11 that I think I might have, actually. I feel relatively confident for the questions I've answered. So of course, I'm not going to get a very high mark out of the 20 because I stopped far too soon and didn't bother with 2 questions because let's say I'm feeling lazy, and in the interest of the viewer, enough stalling, let's actually get to the marking. Going all the way back to question 1, and the tree diagram feels a long time ago now, the probability question. So, according to the mark scheme, P of Q is 0.917, correct, and P Q bar, given R bar has happened, that whole conditional thing was indeed 0.65. Good. Right, diagram. So I had to fill this in, so it's x, 1 minus x, 0.98, 0.02, 0.35, 0.65. Marvellous, I can still do tree diagrams. Okay, of course, the mark scheme being in French, and I can't translate it because it's handwritten. R and R bar is un system complet something. Therefore, R intersect Q and R bar intersect Q is a partition. So he's using a partition. Okay, I get that. But he's using a partition with an and instead of a given. So I could use Bayes' theorem and actually replace. So I could use here, I could use Bayes' theorem. I don't have to, I'm just going to write that I could. Pen's a little bit fat, isn't it? I could have used Bayes' theorem there. But I think I was still going to get the same answer, right? It's 0.917 equals 0.98x plus 0.35 minus 0.35x. Yep, so that's correct. And then we're getting a value which is going to be 567 divided by 0.63. Didn't need my calculator. I knew it'd be 0.9. Good, right, the next one. So this was actual Bayes' theorem. And we're claiming here it's 0.9 times 0.98 over 0.917. Right, so I didn't plug it into the calculator. However, I have the exact same equation as the professor's mark scheme. So I am taking that as correct. Right, binomial. Okay, so... Right, so this is where I needed, again, not having a calculator, to input the binomial, and this reckons for n greater than or equal to 12, you get 0.649. So I have said whichever of these two is closest, so I'm claiming there, again, my fault for not having a calculator, but if I did, then I would actually have the value of 12 that I want there, which means that would work. Now it was the sum. I'm pretty confident with this because it gave it away later, didn't it? So it was 1, 2, 3 for the mean, and then the variance is coming out at 47.355, where of course the comma here does not mean 47,355. This is the European way of using a comma as a decimal point. I do remember that. So 47,355, great. Okay, so M is the moyenne dénominateur. Moyenne, does moyenne mean mean? Probably. I think moyenne means mean. So it is the average score. Right, average is definitely a correct value or term that I can use there. 12.3, yes, good, divide by 10, and then you divide that one by 100. You do indeed, to get 0.47355. Perfect, right. Chebyshev, I think I got this, but I'm not sure. Probability of M minus E of M greater than or equal to delta is less than or equal to the variance of delta squared. Okay, and the point is you sub in and say M minus 12.3 bigger than 2, yes, is less than or equal to the variance, which is 0.477. Yes. Okay, the exact answer written out here has like done the 1 minus and flipped the inequality, but that's kind of what I was doing down here. But they have got the same value as me, where you're getting 0.88 something something, which is definitely bigger than 0.8. So it's the same kind of argument I've used for that. And that's it. Okay, so I think we seem to be in agreement on everything, right? Okay, I should have used a calculator, but I outlined everything I want to do. You know, it's quite nice having more time to actually get into the questions, to be honest. Like, didn't feel like I knew I was taking my time and going through them, but I feel like in a lot of the other exams I've done, there's this sort of like voice in my head being like, hurry up, Whereas here I was like, I have an hour. An hour is a very long time to think about the question. So I felt like I was a bit more relaxed when I was doing it compared to perhaps some of the others. And possibly is why I made fewer mistakes. So I think that's 5 out of 5, right? No, not a triangle. Not quite sure what's happened. Keeps taking my things and turning them into shapes, which is not what I want. All right, question 3 then. So where is that one then in this mark scheme? Okay, here we go, question 3. Right, so first of all, we just had to work out where these points were, didn't we? So f of minus 1 is minus 2. Yes, said that. And it's the gradient of the tangent, which is 1. Lovely. Right, now there's a lot of talking, which obviously is now going to be written in French, but okay, it's not convex between minus 2 and infinity, but it would be in the region of the tangent. So it's claiming between minus 1 and 6, for example, you could say it was. So I've said between minus 1 and 0.4, because the graph actually only goes up to 0.4. Does it? Oh no, it probably goes further than that. I may have... No! What does the graph look like? I need to bring that back up. So the graph here is going 0.4, 0.6. Oh yeah, it does. It only goes to 0.6. I stand by my... So I think the professor there is being a bit fast and loose with all the way up to 6. Oh, it says minus 1.6. Commas. I'm interpreting commas there to be between two numbers, right? It's saying around 1.6, you could argue that it is convex around that point. So I can see it's convex on the graph. So I think what I've said there is okay, right? That was the point. It was saying we can't assume it's therefore always going to continue with the same behavior. I'm happy with that. And it seems sensible to say there is only one solution in the environment. Yes, clearly, right? Felt like a weird question. And we wanted to say 0.1, right? Yes. Phew, right, and it was 0.1 based on the graph. Good. Part B. Okay, so the limit as we go to minus 2 of the quadratic was minus 1, yep. And the log goes to minus infinity, so the function goes to minus infinity. And what does it mean graphically? Vertical asymptote. Even I can translate that French. Lovely. Okay. Calculate f prime to be 2x squared plus 6x plus 5. Yep. Having done a product rule. And the professor has used the product rule there as well, not the quotient rule. Very nice. I don't know if that's more generally you don't learn the quotient rule in France, or whether that's just like how us university level people tend to do the product rule, because the product rule is the quotient rule is a specific case of the product rule, right? So I'd rather just use the product rule in any situation is how we think about it, right? More general result rather than the specific result for the quotient. Okay, now I'm trying to argue what, saying the discriminant is negative, right? So I did show that. Well, I didn't say the discriminant was negative. I showed that the roots were imaginary. Oh, this was the weird table thing. So it wants me to say, gosh, it's going from minus infinity, from minus 2, it goes from minus infinity all the way to plus infinity, just increasing. I think I've just kind of said that, right? I've kind of explained it on the graph. I've said f prime is positive, yeah, which means f is always increasing. I mean, I didn't write the phrase f always increasing. Maybe I could have written that implies f always increasing. So I think there, if you remember me doing this question earlier in the video, this was like this table of values thing, and I had no idea what that meant. So it would appear, based on this mark scheme at least, that you were meant to talk about how the function changes, right? I mean, I've drawn the graph and I've labeled various points. So I think what I've done there is fine, but maybe you could argue I've got like missing some of the technicality of what a table of values means. I've never heard of it, so I didn't know what to do. But I think I've written down correct things. All right, now it's continuous. It goes from minus infinity to infinity, so it must cross 0. Oh, okay. Yeah, so I've said f is negative and f is positive. I guess plus f continuous, sure. I mean, again, this whole question to me felt odd because we were like, I was being asked to write out things or show things that were just like clearly true on the graph, right? So it's, you know, it's asking me to show that f has a root near 1. Like, look at the graph, it does. And we've been told that the graph is the function. So it kind of felt a bit like, what are they actually asking me to do here? Like, if I hadn't been given the graph, I agree, right? We're trying to like deduce what the graph is and we're trying to draw it and figure those things out. But once you've got the graph, a lot of this stuff is like, you know, of course f is continuous because it's drawn in front of me. We know it's continuous between -2 and 0.6 because it's a continuous single line on the page. So like, I wasn't necessarily thinking in that language. But fine, you could, right? I've said f was negative and then becomes positive, so it must pass through 0. Maybe there's an argument there that I could have said, by the intermediate value theorem, there exists a point where it is 0. Oh, he says, as jokingly, I look at the solution and it says, de la value intermédiaire d'après theorem de la value intermédiaire, the intermediate value theorem. Okay, maybe I could have written that. I think what I've written is fine, but I will just make a note to say, by the IVT, by the intermediate value theorem, if I want to really clarify why it must cross through 0. And it reckons 0.12 from a calculator. I mean, that's cheating. À la calculatrice, alpha is this. I'm going to argue that my Newton-Raphson process is much better than that. Should I check what this is actually? I'm going to look at what my answer is equal to because I'm intrigued to see if I do get 0.12. So let's just plug this into a terrible online calculator. And I think that is going to give me 0.02. So this would actually be approximately 0.12 smiley face. So again, I didn't have the calculator, so if you want to complain, you can complain, but I stand by. I wrote out the correct equation. I just need to input it, and as we can see, I got 0.12, which is the same as the professor's mark scheme. So lovely. Right, having those. What are we doing next? We then had to draw a picture. Oh, this is the table of values thing. So it wants me to say how f is changing. F is -infinity through to infinity and changes sign at alpha. That's exactly what I've got. And it's also shown f prime, but I've just worked out f prime as going from negative to positive. So again, I didn't know quite what it wanted there, but my picture looks sort of like theirs. I'm certainly conveying the same information as their picture, so I'm having that. Right, and then what are we got to do now? Second derivative, yes. Oh god, this bit where it wasn't working at first, was it? So it's 2x squared plus 8x plus 7 over x plus 2 squared. Right, so I got that. And now we're arguing the bottom is positive, yes. We're arguing the top has roots of -2 plus or minus root 2 over 2. Get in. And I'm going to say that one of them is less than -2. Perfect. So now in the picture we've got that bit which is concave and convex. Yes, that's what I said. And therefore it changes at that point. Glad I got that one because that actually felt quite involved, actually. There's a lot happening there. And then finally part C. This was a very, very long question why I lost the will to carry on, I guess. This one was long. So I'm writing and using Pythagoras' theorem. Yes, by gx minus 1. That's what I've written. Beautiful. Cool. Number 2, okay, so we're combining all of the bits to get h prime is negative and positive. Amazing. To say that h is decreasing, they've got a nice downwards arrow. So I'm going decreasing here, and then so like h here is decreasing, and then h is increasing. So it looks like that, doesn't it? If I draw that picture. Fabulous. Okay, cool. So I think that's fine. And then the minimum, it must be a minimum. Yeah, I mean, I'm assuming what I've written there is fine. Cool. Great. And then finally, the bit where I messed up my derivative. I knew it needed to be -1, and I was like, why is it not? So g prime is 1 over that. And it is, of course, g alpha minus 1 over alpha. For the other thing, you take their product, exactly what they've done, and you get -1. Right, so I reckon if you want to be really mean, right, I am not going to penalize myself, but you could, I guess, argue I could have been more careful. Gosh, what was a long question. I could have been more careful with that intermediate value theorem sort of statement and the fact that the function must be continuous. Like, to me, it feels like I don't deserve to lose an entire mark, given that whole question was out of 6, right? To lose one of those 6 just because I forgot to state IVT feels to me very unfair. So I'm going to claim that I think it's 11 out of 11, but I guess, I'm sure someone watching this will be an actual marker. Maybe you're going to give me 10 out of 11. But either way, right, again, fully acknowledging I haven't done the full 4 hours and all 4 questions, but I have done more than half the exam in a lot less than half the time, or at least definitely less than half the time. I think I have pretty much got full marks. So all that's left to do is to rank the French Baccalauréat General Mathematics Day 2 exam on my tier list. Now, for once, I actually have the list in front of me, so I can remind myself where I have placed previous exams and therefore where the baccalaureate fits compared to them. Because my first thought, without looking at the list, what exams did it feel like? There was a lot of stats. It felt like quite hard stats, right? Like using Chebyshev's inequality definitely doesn't come up, or at least I've not seen it come up, until university level probability. So that was advanced. The partition theorem was also advanced. What was it? Where we were using the sample mean and the sample variance stuff, quite advanced again, linearity of expectation and variance. So I think that to me felt, at least the second part of the question, kind of like an exercise I might give to my first year university students when studying statistics. An introductory one, but still I think it would be a question I would not think they would have difficulty with, but something that could be like good practice for them. So therefore, I'm thinking this is like on the harder end. But then the second question, okay, I kind of took my time with it and I did make a silly mistake or two, but fortunately spotted them. Do I think it was a bit confusing with how the question was set up? Were the concepts that advanced? We did some derivatives. We took some relatively straightforward limits. We did a lot of like how second and third derivatives influence functions. They massively overcomplicated it by introducing h in terms of g in terms of f. That was needless, in my opinion. But is that advanced? That felt like hard, maybe like further mathsy, maybe. But then the stats stuff felt like harder than that. So, and again, it's a very long exam. I'm kind of tempted to like put it somewhere near the IB, right? And I remember that IB was tough because I found it hard to get through everything in the time. So if I now look at the list, the IB I've got IB close to A-level further maths, right? And I've said just then, now thinking about what I just said and now looking at the list, it felt kind of reminded me of the IB, but it did have some concepts that felt kind of further mathsy. So maybe it's going between the two, right? I feel like, given they were the two that I mentioned before I looked at the list, I feel like it's got, and they're next to each other in my current tier list, I feel like it's got to go between the two. So I think it's definitely easier than the Turkish exam. I'm not sure that's ever going to be beaten. It's definitely easier than STEP. I feel like it was harder than the Arbiter, though that had that horrible sphere question, remembering back, but I think it was harder than that. Scholarship calculus, I'll be honest, I don't really remember the New Zealand one, but it's a scholarship exam, so I assume it's quite tough. It felt like IB. You know what? Let's put it between IB and A-level further maths. So interestingly, let's say, I am claiming the French Baccalauréat General mathematics exam, I think, is very similar, but maybe a tiny bit harder than I found the International Baccalaureate, the IB exam that I did a few years back. So again, if memory serves well, I think that one was tough for the time. This one felt nice on the time, but it was really involved and it really brought together a lot of concepts. So there you go. Not only is the French Baccalauréat General Mathematics one of my favourite exams that I've done so far, it's also the 4th most difficult as ranked on my tier list. Thank you as always for watching. If you have enjoyed the video, then please do remember to subscribe to the channel, and then you'll be amongst the first to hear about the next exam that I'll be taking from a different country somewhere else in the world. I'll see you soon. Take care.